Okay, let's start off with getting our centers. So this is done the same way as we did with the 4x4 supercube and the Lan rhombic dodecahedron supercube. Exactly the same thing. Starting off with this guy, because this is a 4x4, we don't have a center within the center, so we're going to have to define that. So before embarking on the solves, I wanted to go through the concept of parity, which I've kind of assumed that everybody knew about, which I'm sure you do, but just to not make any assumptions and just to further clarify that, what exactly is parity and why do we have it? We don't get that with 3x3s, and the difference between odd-even parities. To anyone who's ever done, say, a 4x4 or a 5x5 or the supercube variations of that species, I'm sure that you sat there in quiet consternation when you have that situation where you're trying to rotate your edges here and you see three that are in place and one that's flipped. And the question is, why does that happen? Strictly speaking, parity is a situation where you have embarked upon what's called the fallacy of false equivocation, where you assume that two pieces are exactly the same when they're actually not. When you take a look at these two colors, or these two edges, you see that they look exactly the same, that they're pretty much interchangeable. But when you look at the internal pieces, you know, how they look on the inside, you see that they're organized a little bit differently, which means that they're not equivalent, but I have no way of knowing that just by looking at it. So inevitably when you're solving this and collapsing it down to a 3x3, you're trying to solve for these edges, and you're really saying that basically they're exactly the same thing, although they're really not. So what you might actually do is, as you're putting the edges in, you might flip them over, or you might put one on the other side or the wrong side, so to speak, and you won't know that it's on the wrong side compared to the others until the very end when you see that it's flipped upside down. So imagine if you wanted to swing these the other way and interchange them, they're not completely equivalent, and when you do change them, they'll be flipped. And there's no way to know if all of these are flipped in the right position until the very end. So that's why you get parity in the even ones. But what about the odd ones? You'll notice that you might get parity, but you'll get it early on before you've actually completely collapsed it to a 3x3, and you almost never get the situation where you have three edges that are in and one that's flipped. The reason for that is because you have what I would call a keystone. You have something here in the middle that helps coordinate things. These two look like they're equivalent, but if I were to flip these, they're going to look like they're upside down when compared to this guy. So as I'm putting in the edges for the first time, I'll know that they're wrong, and I'll fix the parity before I bring it to the end solution here. So that's why you'll get certain parity situations with even numbers, but not with odd numbers, because I have a key here. I have a center edge that can guide where I'm supposed to put these two. The problem with even ones is you don't have a center edge to guide you, so you can end up with a bunch of flips and not even know it at the very end. This is especially useful when dealing with what happens with the supercubes. So with the supercubes, these two are pretty much interchangeable so far as you know. And you're not going to know that you put them in wrong in connection with everything else until the very end when you see that these are flipped up and only one is flipped down. But with here, even though it's a supercube, I'll know how to put them in based on the orientation that's guided to me by this. So that's why you're able to put the parity back into position even before collapsing it down to a 3x3, so you never run into that. And that makes that end portion of any even cube challenging because you don't have a middle edge by which to go by. The other challenge that's different between the evens and the odds, as you already know, is the fact that with the even numbers, with odd numbers rather, I also have a keystone that tells me where my centers are supposed to be. So I don't have to hunt for it and fish for it. So here's the 5x5. This is always going to be green, this is always going to be yellow. That's as opposed to the even numbers, you have to define your own centers. So I could put the orange one here, and instead of blue, I might accidentally put the yellow one there. So what I need is, since I don't have a way to guide it through the centers here, I have to use the corner pieces. Now this is a review to most of you, but I'm telling you, as we start to solve these monsters, there's going to be some issues with the even number ones that we have to bear in mind. So I'm just going through some of the basics right now. So the issue here is I have the I know where my even ones are going to be, but everything else is pretty much equivocal. These guys are interchanged. When it comes to the supercubes, not only do I know what color it's supposed to be, I also know the orientation that it's supposed to be. So if I start to solve these guys and I start to solve the centers, I don't have any problems with orientation because this will tell me what's supposed to happen. Then I solve these middles here, and that further tells me what these corner centers are supposed to be. Otherwise, they could be equivocal, like over here. So if I put these in place, I'll have it in a certain orientation, and I'm going to use this orientation to decide where this is supposed to be as well. But I don't have any center edges, nor do I have a center piece, a middle piece to really orient that. So I can get messed up, put the wrong center in over here, and I have to basically organize it like that. Now in terms of orientation, generally for these cubes that's not a big problem because each of the edges are different. So as I'm putting these in, I know which edge is supposed to be here, and none of these are equivalent to each other. This is different from this is different from this. So because of that, I'm able to guide my way through there, which makes it easier for a supercube. With this guy, these are pretty much equivalent. It doesn't really matter. It only matters over here. But we're going to come across we're going to actually come across a further issue, a further parity problem when dealing with these guys. Because understand, and to use this as kind of an example, what's unusual about this is that none of these edges are equivalent to each other, and none of these edges are equivalent to each other either because they have two different colors. And yet with here, I've got three edges that go in completely different centers that are completely, apparently equivalent to each other. And by being equivalent to each other, it could lead to some interesting parity situations. What's more, even my centers have potential equivalencies over here. So bear that in mind, because that's why with the even-numbered puzzles, you have the potential for an extra bit of parity and extra bit of complication that you don't get with the odd numbers. We're going to see how this translates in terms of the solving of these puzzles. So, like any supercube, I'm just going to solve the centers and bring it to the last two centers. But understand, as I'm putting this in, I have to orient myself appropriately to where things are supposed to go. So, why don't we do the green and white over here? So here's green and white. Right now, I can do any kind of orientation that I want. This is in association with the white. Let's put this in an association with the green. Might as well do this one here. Turn this here. Turn this down. Bingo. Now, there's a couple different ones I could have used. In most of these other supercubes, there's only one that's going to be associated with it. But it didn't have to be this green. It could have been another green. It could have been, say, this one. So, which one goes next? Well, it's obviously a white one, and a green one. Let's stick with the greens. Now, I run the risk of putting the wrong center next to it because, again, I have these guys, the middle ones, to guide me what's supposed to be next, right? But I don't have one over here. So what I'm going to have to use to guide me, just like with the supercube, is a corner. So what corner has the green and white? Here's a green and white over here. It's the wrong one. The green is facing here. I need to find the green and white corner piece that's facing here. Anyway, here's green, here's white. So now I know that the next one is going to be green and yellow. So that's all I need to know to set things up over here. And we've got our final two. Our final two centers. So we're going to put those in. We know that over here, this has to be the green one. I'm sorry, this has to be the white one over here. White and red, so that's what I'm going to be moving these in. I'm going to be moving these down here. So I'm going to move it like this. And I'm actually going to move this down here so it can meet, this red can meet this red over here. So down, turn, and up. So that's where it needs to be. Okay, this is where we get into that dreaded last two sides situation. And that last two side situation is going to be to bring this, yeah. So it's just it's that algorithm that we've seen before with this tutorial and this tutorial, and just doing the last two centers. And what this algorithm is going to do, of course, is going to move this to here, this to here, and this to here. So what I want is one solid one on one side, which I have here, then a solid one on this side. So what if I were to move just like so. Move this up to here, and that'll match this side over here. And that algorithm is has been posted in previous tutorials. I'll post it again here. Forward, back, back, forward, boom, boom, and down. Okay. So that put this in, and now I've got 3 here, which is good, because this algorithm doesn't touch these guys. So what can I do to start moving these in? So why don't I move this down here? This will come here, this will come here, this will come here. So that's a good start. So forward, forward, back, boom, boom, and boom. So this is in, this came up here. I move this over here. There we go. All right. So this will come here and solve it. This will come here and solve it. This will come here and solve it, and we'll be good. We'll be good with these 2. Turn. Okay, so we have all these guys in. Now what I think I might also do at this point is check and see if all these are where they're supposed to be. You'd think that they would be. If this were in place, then by necessity everything else should be in place. All right, so this is in line 2. You can see that this over here is where it needs to be. So things are looking good, and from here I just continue with the solve by getting these in the usual manner. I'm going to put in the centers on this one, and then make it to the last 2 centers here as well. This is how I'm going to coordinate it, kind of putting them all in at the same time. So just like with this, why don't we start off with the green and white. So this is just like a 5-layer supercube. And with the 5-layer ones, I got it down to the last layer over here. The first thing we want to do is we want to put in edges. So to put in those edges, we're going to be making use of what we've seen before, which is middle swaps, adjacent middle swaps or opposite middle swaps. So let's see what we've got. None of these are really in place. Now this one, because it's just a pillow of pyramids, it's a little harder to see where things are in terms of shape. The rouleau formation actually brings the shape out a little bit more. But in any case, all I want to do at first is rotate these around. So if I hold this fixed here and do my RU, RIU, that one, these will start to rotate until I get something that's supposed to be where it's supposed to be. R, U, RI. U, R, 2U, RI. Okay, so what we see is this is where it's supposed to be, this is where it's supposed to be, and these 2 are flipped. Now we have to be careful. Let's make sure that this white doesn't belong over here, and as you can see, it follows the right contour. So this is okay. So now what? How are we going to flip these guys around? Well, we do have an algorithm to do that, and that's where we hold it here and just do the R2U, R2U, R2U until we get that back. We'll just move it like this, and that should be able to flip these 2 around. We could do an adjacent middle swap, but we're going to end up in a little bit of a problem in that we're going to create parity on this side, which we don't want to do. So we have R2U, 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 and R. So that puts these into place. Did we screw anything up? Nah, we're good. Let's make sure these are where they need to be. I'm not so sure anymore. I'm just wondering about this white, to be honest with you. It looks like there's almost a cleft here. Yeah, I'm going to say that these 2 are not where they're supposed to be. These 2 are fine, but these 2 are not. Because you can see just a little bit of a cleft here. So what I'm going to do is I'm actually going to do, we're actually in that situation that I thought we might be. I have to flip these 2 around by doing an adjacent middle swap. So as you recall, that's going to be 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Okay, so that did swap those as wanted, but it also rotated that. So now everything is within 180 degrees of where we want it to be. But I did create parity here. So what I'm going to do now is I'm going to basically do an algorithm that sort of swaps these guys around. This is going to rotate, so these two are going to swap, but it's going to take this with it, so these are going to rotate, and these are going to swap. So basically, this side should be solved, and this should be opposite. That's 2R, 2U, 2R, 2U, 2R, 2U. So, yep, as promised, these two are solved. I took the parity out of here, and now I just have these two that need to be put as opposites. So that actually looks better, less of a cleft there. So I'm going to turn this here and do exactly the same thing to rotate these two. Because I don't want to do the same algorithm. You might say, well, just do the same thing, but I'm going to create parity, which I won't be able to get out of. R to U, R to U, R to U, R to U, R. Okay, good. So that just looks better. That feels better. We're in the right place now. So I almost got tripped up there a little bit. So we have the middles here. Now we do the edges. Now we can ignore the middles now, and these should all be in as well. And we're going to put these edges in the same way that we put in this guy. We just had to deal with the edges, but now we're doing corners. I'm sorry, I meant to say corners. So let's see what's in. What needs to happen is this is all solved over here. This is not. So I want to get one that's solved on both sides. Are there any that are in and there aren't? Now I'm going to turn it from this perspective now because I know that I can move this around like this, and these three aren't going to change with the algorithm. We're just going to be moving these guys down. So if I wanted to make one side and make it right, then I would move this to here, and this would move here. So all of these should be right. So let's try it. And it's that same algorithm. Okay, so that put that in here. So now I'm going to turn this, really, any one of these. Okay. So it appears that both of these just have one out. So what can we do? Well, I'm going to make use of the fact that I can interchange browns. So forward, back, bang, bang. Now, with these 3 cycle turns, notice I don't have a planned out strategy. I don't like memorizing algorithms like that can do that, because it just kind of takes the fun of problem solving out of it. So I realized that you could memorize a way to quickly get it in, but what fun is that? Anyway, I can move this here. This won't change, and I want to cycle things around a little bit. But how can I do it? Because this will come here and solve it. This will come here, not quite. So I'm going to come back down to here. Nah, I don't like that. Okay, I think this might work. Bring this down to here, it'll solve it. This down to here, and this up here, and see what happens. The only problem is that these two may be very different, but let's see what happens. So, okay, and I like it. So now all sides are solved. And just like with the previous one, let's put these into position, and these are in place. Okay, so all of our centers are in place with this one. This big guy, this 7-layer thing. And it's really the same as 7-layer, the 7x7x7. Same kind of thing, but we just have to make sure that we're orienting things right. Because this is a odd-numbered layer, we don't have to worry about establishing centers like here. Once we get the 6x6, along with the 4x4 we do, but it's already laid out here. So basically I'm going to be filling in these centers here, same way that we did here, and just kind of get us to the last 2 centers. So continuing with this guy over here, I put in the first layer as well. The first layer, I put in one of my centers, and the thing to keep in mind, the thing that was kind of fun about this is the fact that I kind of had to use palpation in order to kind of feel which little square goes where, because I can't just rely on the color. I actually have to rely on the shape. But herein lies one of the advantages of the pyramid shape. Although we have the same number of centers, we don't have the same number of colors. So I can actually use different greens to go in here. I didn't have to use this one. I could have used one that would normally go with the red and green side. So I do have a little bit more variability, so it might go faster than you think. Okay, now we're down to the last two centers of this big guy here. So you can see this is all mixed up in various positions. So the strategy with this is I'm going to divide it into sections. I'm going to start off by putting these guys in with the centers here and the quote corners over here, or rather the edges here and the corners here. Then I'm going to do the larger area here. Same kind of thing by putting these edges in. Here, 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 and here, and these corners over here. We have to do something different with these guys. So we'll kind of start off and decide exactly what we did before. This one appears to be in place. These guys aren't. So this actually becomes easy. This is the configuration that's the easiest to solve. But I'm going to be moving it with this. This is going to be my R move. So we have R, U, RI, U, R, 2U, RI. And another rotation like that. There we go. So now notice all these are in place. So to get a side here, maybe I'm going to try to put this one in by causing this to flip down over here. So to do that, I'll flip this over here, which will flip it down, then we can try to flip it back up. That might be the best bet here. So that's going to be just moving from this side. Alright, no matter what I do, these will always be fine, and these will always be fine. So what it is, I move this over here. Why don't I move this brown one into position? Just like this. First thing I'm going to do is check and see if this brown one will fit well. Yeah, it's pretty good. It'll fit. The reason why I'm doing that is I don't want to mess up what I have here, which is what would happen. So we'll do the same algorithm. So we've got actually two sides that are solved here, which is interesting. Because when I move this here, none of these will be touched, as you recall, and I'll just be cycling pieces here. So what can I cycle here that might help? Well, this can cycle down to here and solve it. This will cycle here and solve it. This will cycle up here and solve it. So we should be able to get all of our inner areas, our 3x3, basically. So let's see what happens. And lo and behold, we got it. So we placed these in. So far we're doing well. Now we do exactly the same thing, only with these guys. These guys are already placed, so I don't have to worry about that. These guys weren't touched. But what about over here? Well, this needs to come here. Or is it this that needs to come here? So we want to make sure that they're all either placed or within 180 degrees of where they need to be. Flip-flop these two guys and see what happens. So this really needs to be here, so it's 90 degrees from where it needs to be. So we apply the algorithm that we know so well, which is okay, so it did some rotation and flopping and gave me the expected parity over here. So this is within 180 degrees of where it needs to be, as is this. You know that this doesn't belong here, which means that this does. So what I need to do is I need to do some flip-flopping. This is 180 degrees where it needs to be, as is this. I can tell because it's flush with this over here, so I know that it fits along in here. So These two are fine. These two need to be adjacently swapped, which should take me out of parity and hopefully put things in to where they need to be. Because as this swaps with this, everything's going to rotate. So, see what happens. Parity was taken out, and let's see what we got. And these are all put in. So we've put these into configuration. So we're doing pretty good. Now, same thing with these sides over here. Down over here, we see that this is in, this is in. So we have a nice three, we have a nice two corners. So I'm going to want to put this on the top, because by putting this on the top, then I will only be cycling one. So I'm going to put this over here and move this like so, because I know that these corners aren't going to be touched, but this is. Okay, so this did come in here as predicted. These weren't switched at all. This brown will come over here. This green will come over here. This brown will come up here, and actually won't really affect that. So this should give me a side. So okay, wow. Okay, so that's it. So basically, the only thing I wanted to do was put something here that I can turn down and not have to worry about, kind of protect that, and start rolling things into here. So this is all kind of fixed on these sides, and that's not exactly what I wanted to do, but what I do want to do is I want to roll in a brown one here and the proper, well, actually this needs to come over here, this needs to come over here. So if I go like this should be good, because I'm going to save these guys. These won't get rolled in. But this brown will come here. And ultimately, I'm going to have to put a green one in here. So actually, this green will come here, which will fix it. This will come up here. And this will come down here. All right, so as anticipated, that's what happened. So this eventually has to come over to here. So this will come here, this will come here, this will come. So basically 2 cycles, 1, 2 will solve this, 1, 2 will solve this, and 1, 2 will solve that. So that's the kind of the advantage of having one thing that can go to multiple places, one color and one shape. So let's do it once. So this next one should put all the rest of the corners in place. This to here, and this to here. Let's see if it works. It's so crazy, it just might work. Okay, these are where they need to be, and all these corners, believe it or not, are where they need to be, even though these are in. The only thing that I'm looking at here is just this line is straight, this line is straight, and these corners are all like kind of like a tic-tac-toe, or kind of like a crisscross, are all in place. So everything is where they need to be. Now it's a question of these guys. So what are we going to do to get these guys in? And that's the last frontier in terms of putting the centers. And this is the unique challenge that the higher order crazy puzzles, not crazy, the higher order super puzzles can offer.